main challenges of machine learning. Clear? That means before starting a machine learning project or a machine learning model, okay, so we have to remember some challenges. We have to keep in mind some challenges of machine learning. Okay, so first challenge is not enough training data. Okay, so here the training data means to which data we are applying the machine learning algorithm. The data we are called as a trained data. In general, the data may be split into two types. One thing is trained data and test data. Validation data is also there, but till now we have to remember only two things: trained data and test data. Here the training data means to which type of data, to which data set we are applying the machine learning algorithm. The data is we are called as a training data. So not enough training data. That means if you're having only a small amount of data, then we are trying to apply any machine learning algorithms. Maybe that machine learning algorithm or that model does not give the good performance. Okay, so minimum we have to take the thousands of examples, okay, before applying the machine learning algorithms. Like if you're taking the some 100 records or 1000 records, by using the 10 records or 1000 records, if you are trying to build a machine learning model, okay, the model may not be give the uh, good performance in real-time scenarios. So minimum we have to take the thousands of examples before applying the machine learning algorithm. Another category is poor quality of data. What's called as poor quality of data. That means in general we are applying the machine learning algorithm to which type of data? Training data. If you're having the training data is error, let us assume, okay, if having the training data, if you're having errors in the training data, obviously the model is also not given the good performance. Okay, that is called as poor quality of data. Before applying machine learning algorithm, we can also check the quality of data. The quality of data, that means the training data must be having some quality. For that we are having different data quality techniques, or we are applying different data pre-processing techniques. Okay, by using that one we have to improving the quality of data. Okay, how we are improving the quality of data we will see in the later lectures. And irrelevant features. Okay, so before applying machine learning algorithms, uh, it's not necessary what are the features we are having in the data set. All the features may not be needed in to machine learning algorithms. Maybe the data set may having some irrelevant features. What you have to do is before applying the machine learning algorithm to the data set, we are identifying the irrelevant features. We are identifying the irrelevant features, then removing those irrelevant features by applying different feature engineering techniques. For example, feature extraction, okay, feature selection. Such type of techniques we are using. By using the feature selection, feature extraction, okay, we are removing the irrelevant features. So we are uh, pick only relevant features. Those relevant features are given as input to the machine learning algorithm. Okay, that is one another challenge. And non representative training data. Okay, that means if you're having a non-representative, if you're considering a non-representative training data, there may be chance to occurring the model with some bias. Clear? That means there may be chance to occurring the more error if you're not, if you're considering the non-representative training data. The training data must be a representative training data, then only we are getting the good machine learning model. And another important concept is overfitting the training data and underfitting the training data. Overfitting the training data and underfitting the training data means, so as we know that the training data means the data that is used as input for machine learning algorithm, that is called as a to build a machine learning model. We are using the machine learning algorithm. To that machine learning algorithm, we are providing some input data. That input data we are called as a training data set or training data. Okay, so now overfitting means to improving. What is our ultimate goal of machine learning? To build a good performance machine learning model. That means 100% accuracy machine learning model or 99% accuracy machine learning model. That is our ultimate goal. So to build a high accuracy machine learning model, okay, so if you are trying to increasing the training data, if you are trying increasing the training data, or if you are tune the model to getting the better performance, to getting the better performance, then the model maybe works fine for training data. The model may also works which on training data. But the model, after building a model for training data, if you check that model for test data, but the model does not works fine for the test data. That means the model works fine for training data, but the model does not works fine for which one? Test data. That is the concept of which one? Overfitting. What is meaning of overfitting? So as you know that data may be training data or testing data. Okay. So that means after building the machine learning model, after building a machine learning model, that model gives good performance for training data or high performance for training data and less performance for test data, are also called as that model given low error for training data, high error for test data. That is the concept of which one? Overfitting. Underfitting means reverse. That means we are building a training data. For example, if you are trying to build a model with small amount of data, maybe that model may be suffered with a underfitting. Okay, so if you are build a machine learning model, okay, by using different machine learning algorithms, if that model give low accuracy for training data, low accuracy for test data, then that model is suffered with a underfitting, or it gives the high training error and also high test error, then model is suffered with which one? Underfitting. Okay, so we can also keep in mind, okay, so we are trying to building a model without suffering that model with overfitting and underfitting. For that we are using different concepts. Okay, by using some hyperparameter tuning, there are some concepts are there. By using that concepts, we are trying to build a machine learning model. Okay, but that model does not suffer with a underfitting and overfitting. Okay, these are the some of major challenges we have to keep in mind before start any machine learning project.